Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. So, today I thought we'll take up vertical movement of the particles,
Mhm.
free fall, we call it. So, under the acceleration, rather, the force with which the Earth attracts all the particles on this planet, which we call gravitational force, acceleration due to gravity, all the particles fall towards the center of the Earth. So we'll look into those examples and see how do we find velocity, acceleration, and related questions can be solved in this situation. Okay.
Yeah.
So let me share with you the material which I have created. Oh, well, there we go. Perfect. So vertical motion under gravity, that is what we are going to study today. Amy, can you please read this?
All objects tossed up will fall on the ground with a constant acceleration if somehow the effects of air resistance can be eliminated. The acceleration is independent of the object's characteristics like mass, density, or shape. An object moving vertically under the gravity can therefore be modeled as a particle with a constant downward acceleration of g equals 9.8 meters per second squared.
Perfect. In earlier units, you have derived these formulas: V equals to U plus AT, S equals to
Yeah.
UT plus half AT square, V square minus U square equals to 2AS. We are going to use the same formulas because
Okay.
they were derived for constant acceleration, correct?
Right.
They were derived for constant acceleration. And in vertical motion, acceleration is due to gravity, which is constant. So
Oh,
once again, we
okay.
have the constant acceleration. The only thing is now the value of A for all our examples will be 9.8.
Mm-hmm.
Another important thing here is that, as you know, acceleration could be negative or positive. Now, when we say 9.8, we know that this force or this is direction is downwards, correct?
Yeah.
So, when do we take G as negative? When should we take it as positive? Well, if you are considering throwing some object upwards, correct? In
Mm-hmm.
that case, we'll take G as negative because you are
Yeah.
making up direction as positive.
Right.
But if you're considering movement, which is downwards, right? In that case, G will be positive because it is helping it out, right?
Right.
It is in the same direction. So the direction we are very flexible with. You need to define it. So if the direction is similar to downward force, we'll take G as positive. Clear?
Okay. Yeah.
In many examples, you may have a case of throwing a stone to bring down these apples, for example, right? This is a picture from our garden, actually. So
Oh,
yeah,
right.
we had huge tree and a lot of apples on it. As you can see, so many of them here in this picture itself, right?
Mm-hmm.
So
Yeah.
you kind of throw the stone and it comes down, correct? If you want to find the maximum height a stone reaches, in
Mm-hmm.
that case, G will be negative because you're interested in the path of the stone going upwards,
Oh, yeah.
opposite sign. But if you want to find how much time does it take to come down, an apple, for example, how much time it takes to come down, both will be positive, velocity and gravity. Is that clear to you?
Yeah.
So that
It's
is
something
a
that.
very important note. And based on this, the questions we are going to take of 6 examples. Now, these are the examples which we are going to take one by one. Can you please read from question number one onwards?
Okay. Question one. An apple falls from the height of 10 meters. A. Find the time the apple takes to reach the ground. B. Find the speed with which the apple strikes the ground.
Right.
Question two. A ball is thrown vertically upwards from the top of a building, 21 meters high, with a speed of 18 meters per second. A. Find the greatest height above the ground reached by the ball. B. Find the duration when the ball was in the air.
Correct.
Question three. A particle is projected vertically upwards. Show that it takes as much time rising as it does fall to the starting point.
Correct.
Okay. Question four. A particle is projected vertically upwards. 2 seconds later, the particle is moving up with 1/3 of its initial velocity. A. Find the initial velocity. B, find the time to reach the maximum height.
Correct. Example 5 and 6.
Question 5. A particle is projected upwards, reaching the greatest height of 100 meters. Find the duration when the particle is 70 meters above the initial point.
Mhm.
Question 6. A stone is thrown vertically downwards from a point 100 meters above the ground with velocity of 6 meters per second. A, find the speed with which the stone hits the ground. B, find the time it takes to reach the ground.
Perfect. So I've tried to take all the type of examples which you'll normally see under this topic, correct?
All right.
We'll now see how do we use these three formulas, which is V equals to U plus AT, S equals to UT plus half AT square, and V square minus U square equals to 2AS to solve all these questions, correct?
Mhm.
So the idea here is whenever a question is given to you, identify what is given, what you need to find.
Right.
Based on what is given, select your formula, correct? And then solve it. Simple as that. So please read question number 1 and tell me how will you solve it.
Okay. So an apple falls from the height of 10 meters. A, find the time the apple takes to reach the ground. So we need to find the time. So we need an equation with t in it. So it can't
Right.
be the last one.
Correct.
We got the height of 10 meters. So means S is 10. So we need an equation with S and T, which is the middle one.
Correct.
So you would have to use the middle one.
An important thing here is when we say an apple falls from the height, we'll assume that the initial velocity is 0.
0,
Very
right?
important. They may not tell you that, right? It just falls, right? It was hanging there, it falls. So the
Yeah.
initial velocity is 0. That is given to us. And always, 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 acceleration 9.8 is given to us.
Oh, okay. Yeah.
You know A for all the time. So A is given to you, U is given to you, S is given to you, T is what you need to find, correct? So that
Mm-hmm.
is what it is. And the formula, which really connects them all, is S equals to UT plus half AT squared. So plug in the values and find the unknown. In this case,
Right.
you may need the quadratic formula to find the time. Time definitely is in seconds. Displacements are in meters, correct? So that is
Yeah.
how you're going to solve it. Now part B, find the speed with which the apple strikes the ground. That means now you want to find the velocity, the final velocity V, right? This is what you need to find.
Yeah.
You know the initial velocity, right? You know the initial velocity. So the best formula which connects these two is V square minus U square equals to 2AS. A is always known to you. Acceleration is
Right.
always known to you, right? So this is the best formula. You know all the figures. You know S, which is 10 meters. V square minus U square, plug it in the values and get your answer. That is how you're going to do it. Is that clear?
Just yeah, but just to say, if I did use the V equals U plus AT, and I know it's obviously a bit more complicated because T is obviously a decimal or something, but would you
Correct.
still get the same answer?
Yes, yes.
Okay, cool.
Good
Just
question.
checking.
Very, very good. When you've done part 1, you've already done a hard calculation of finding all this. You could use this question, but
Okay.
I will still avoid. You know why?
Yeah,
If
because
somehow this is wrong, if this is wrong,
yeah,
both will be wrong. Okay.
right. That's
But if
true.
this is wrong, you'll still get 0.5 marks for doing the correct method.
Right.
But don't take the risk. You understand?
Yeah.
Don't take the risk. There could be a calculation mistake, and then these decimal values matter a lot. I rounded the figure to 3 significant figures, 1.43, as is expected in most of the questions. But you know, the numbers after this may make a difference.
Right.
So
That's
we have
true.
to be very clear. Do not use the derived values if something else is available.
Okay. Yeah.
Use what is given to you.
Okay. Yeah.
Okay.
And stick to like whole numbers.
What is given to you.
Yeah, what's given.
Yeah. Question number 2. Can you please read this question and then explain me your strategy?
Okay. A ball is thrown vertically upwards from the top of a building 21 meters high with a speed of 18 meters per second. Find the greatest height above the ground reached by the ball. So when it says vertically upwards, that means our acceleration would be minus
Correct.
9.8 because
Correct.
it's opposite direction.
Correct.
And then the building is 21 meters high.
Correct.
Okay. So, and we got this, okay, so it's thrown upwards from the top of a building, 21 meters high. So find the greatest height above the ground reached by the ball.
Correct.
Yeah, so initial velocity would be 18 meters per second.
Correct.
So we've got A and we've got U.
Correct.
A and U.
Find the greatest height. You have to find S, right? So final velocity is also known because when you reach the maximum, final velocity is 0.
Oh, I was just about to ask. So, oh, okay, yeah.
So
That was
is,
like the other question where when it was at the top, the initial velocity was 0, but in this case, the final velocity is 0, right?
so the trick here is most of the questions do not give you all the values. A
Right.
is given to you for always. Acceleration 9.8, you know it. Velocity is very tricky. You have to see like what is happening to this, right? So you're going to the
Yeah.
maximum, velocity becomes 0, right? Just dropped, initial velocity is 0. So that is how you get those values. And those should be identified, and only then you can begin answering it. So we know the two velocities. So v square minus u square equals to 2as gives you the solution for this particular question, correct? So you have to find the greatest height. Now clearly, because you're going against the gravity, so acceleration is against you. So minus value of 9.8 will be taken here, correct? And clearly, you get a distance, which is positive. So that means you did the correct thing. So write down your answer with the units. So I'm not using units in my calculations or for writing the values. However, you should definitely use values, units along with these values and also in the answer, correct?
Just one more thing. So yeah, if you have to think about it a bit more logically, how would I clarify? Because I was about to say that speed was the final velocity, and then say the U, like which way round? How do you know which way round it is?
Okay, so the question is find the greatest height. So we are restricted in this particular domain. Do you understand from here to here?
Yeah.
So in this part of this question, what is we looking at? It has been thrown from here. We know this velocity is 18, reaches there. We know that velocity is 0. And during this interval, acceleration is against us minus 9.8. And we have to find only the distance, s, the height. So it works.
Oh, okay. So 18 is here, 0 is here.
Yeah. 18 is here. 18 is here. So we're
Okay.
looking only that section, that small section.
Yeah. Okay.
Always you can look like this. Do you understand? Now the second part is find the duration when the ball was in the air. Now you just look into this duration. You understand? In the air basically means you start from here and end there, correct?
Oh,
So you
okay.
need
Yeah.
not worry about where it went in between. You get the idea.
Oh, yeah.
So
Okay.
strictly
Yeah.
speaking, the displacement is this distance.
Yeah. Not from that to that, because
So we
they're
know
not
that too.
asking
It
when
is
it was
not
up.
distance. It is not distance. Displacement. So the net change in the height is the height of the building.
Oh, right. Okay.
Net
Yeah.
change in the height is the height of the building. You get the idea.
Mm-hmm.
And height of the building will be considered negative in this case because you're coming downwards.
Right. Yeah.
So the tricky part is what to be negative, when what should be taken as negative, what should be taken as positive. These things
Yeah.
make huge difference at times. So you need to do some examples to figure this out, correct? So the formula is s equals to ut plus half at square, which will give you all this. But then once you get these values, then use quadratic formula to find the value of t, which comes to be 4.6 seconds as calculated here, correct?
So can S always be, I know we're going in the negative direction, but can you always take the absolute value for S?
Yeah, this position P, let's say P is 0, right? Here position is 21. So it is 0 minus 21, displacement, right? Delta D. Final minus initial.
Yeah.
Therefore, it is minus 21.
Yeah, but I was saying like, yeah, so I get that it's minus 21, but like, could we just take the absolute value or no?
No.
Oh, okay. No, because I thought, oh, okay. No, we're not dealing with distance, are we? We're doing displacement. So it can have a negative, right?
Correct.
Okay.
Final minus initial. Okay.
Okay.
So these are critical things which can make huge difference. Okay. So I'll actually upload this video, go through them again.
Okay.
Question
Yeah.
number three. Yeah, they look simple, but they are very tricky, right?
Yeah, they are.
Question number
A
three. Can
part.
you please read? Yeah.
Yeah, a particle is projected vertically upwards. Show that it takes as much time rising as it does fall to the starting point. Okay.
Very important.
So
Always it is true, right? So time taken to rise is same as time taken to fall.
right.
So if you know one time, you know the other time. If
Double
you
it.
know the total time, half of it to rise, half of it
Yeah.
to fall. So that is very important. And very simple calculation. Fine. Let's talk about the rising time, right? So when we say rising time, that means from here to here, correct?
Go up.
So
Yeah.
final velocity is zero for you. So v equals to u plus at, final velocity is zero. So the time taken will be initial velocity over gravitational force. Now this is very important formula. If I tell you that I'm throwing the ball with the speed of 20 meters per second, let us say, then
Yeah.
then the time to reach the maximum height will be 20 divided by 9.8. So easy.
Oh, right.
This
So
is
you've made a little like formula, like
correct.
equation kind of thing.
So it is one of these equations are critical for you. Yes, of course, but this is also very important.
Right.
Time for an object to reach the maximum height, u over g, when you know the initial velocity u,
Yeah.
right?
So you put minus g because when we go up, the gravity or acceleration would be negative.
Yeah, yeah,
Right.
yeah. In the form, in the calculation, yes,
When you substituted a
of
as
course.
minus
A is
g.
minus
Okay, cool.
instead of because we are writing a formula, so it is not
Right.
like minus 9.8, right? Minus g there, and you get
Hmm.
a formula there, correct?
And that
Now,
one's really nice and easy, like to derive from. So I won't really forget it. Yeah,
yeah,
that's nice and clear. Okay.
correct. Now let's consider the total motion. That means going up and down.
Yeah.
Going up and then down means you have covered the whole thing, correct? But the
Right.
displacement is zero now because you started from here
Started.
and you're ending
You
here.
ended in the same place.
So
Oh,
the displacement is zero. S is zero. Do you see that as zero?
yeah.
S equals to ut plus half at square. And of course, this value will be negative. And you rearrange, you get t and t cancel away. And then you get t equals to 2 times ug, twice this time.
Oh, yeah. And it makes sense. So it's like it's true when it is double the like time when you do it, because when
Yeah.
you derive the formula, it's literally 2 times that u over g.
Yeah,
Right.
very important formula also. You could note them as your one of these formula lists, okay? Special cases.
Okay. Yeah.
Yes.
Total time is twice the right.
Now let's see question number 4. Can you please read this question?
Yeah, twice. A particle is projected vertically upwards. 2 seconds later, the particle is moving up with 1/3 of its initial velocity. Find the initial velocity. So so a particle is projected vertically upwards. So we know gravity or acceleration is minus 9.8.
Mhm.
2 seconds later, the particle is moving up with 1/3 of its initial velocity. So a third of u at t equals to 2.
Correct.
Okay. Find the initial velocity. So we need to find u.
Correct.
So
So related with your
v
first formula, v equals to u plus at, write v in terms of u over 3, and then you only one unknown, u is there, solve for u.
Oh, yeah.
Simple as that.
Okay. Right.
So, sometimes they give you 2 velocities, then you can easily do with this particular method, right? So it's like a linear equation, finding another point on the line.
Right.
Okay,
Yeah,
great.
yeah.
Part B, find the time to reach the maximum height, right? Once you find u, you know what the time is. Divide by g. U divide by g. Do you see that?
Oh, I was just about to say, I was going to go through the process saying the velocity, the final velocity 0. I was going to do all of that, but you went straight to it. All
No,
right.
I did all that. I did all that. So
Oh, okay. But
we
you're just telling me how you can just sub it in right into that equation.
ultimately, what do you get? You get u over g, right?
Yeah. Wow, that saves so much time. Oh my god. That is good. Shortcut methods. Love
Yes.
it.
Question number 5, please read it.
A particle is projected upwards, reaching the greatest height of 100 meters. Find the duration when the particle is 70 meters above the initial point.
Correct.
Okay, so S equals 100 meters, because that's the greatest height. We need to find the duration, so T equals unknown, when the particle is 70 meters above the initial point.
So it could be above, is coming down. So it could be 70 meters both ways. Do you understand? So the question is find the duration when the particle is 70 meters above the initial point. So while going up, find the time. While coming down, find the time. So it is this interval which we are talking about. You get the idea.
Where's the initial point at 70 meters?
This is 70 meters.
That's the initial point.
Okay, so let me read it. It's kind of messy. So let's say a particle is thrown from here, it will go up and then it will come down, correct? So we are given that the highest point here is 100 meters. But we want to know when was it above 70 meters? So it will cross this height of 70 meters to reach 100 meters, correct?
Yeah.
To find this time T1. And while dropping down, it will again cross this height. So that time T2. So the duration will be T2 minus T1, correct?
Yeah.
So
because we're doing in that interval, right?
That is the interval you need. So this question is slightly tricky. A particle is projected upwards, reaching the greatest height of 100 meters. So we are given you the height, which is known to us. We know acceleration, which is negative 9.8. Final velocity is known to you this time, which is 0. So you can use initial velocity minus that v square minus u square to find the initial velocity. It's kind of important to find with what velocity was the particle thrown. Correct? You'll see every formula uses initial velocity. So without knowing initial velocity, you cannot solve any question on free fall.
All right. I didn't actually notice that.
Yes.
Wait, is there not even one equation where u is not in?
No. Initial velocity should be known to you.
Oh.
Many times when it is dropped, it is 0. So, they're not saying it, but when you're dropping, it is 0. So if it is not given to you, first thing is find initial velocity, make a note.
Okay. So when initial velocity is not given, find it first.
Yes. There are no two ways about it. You cannot solve the question without that. And that makes this question extremely difficult.
Right.
Now, once you have calculated, then put this initial velocity, acceleration, and you are interested in height of 70, correct?
Yeah.
So S equals to ut plus half at square. Find both the times when it reaches 70, while going up and while coming down. So quadratic formula, get the 2 times, and the difference will give you the duration between that time.
All right. Yeah.
So I rounded the figure to 9 seconds.
And both times when you did the quadratic, it was positive?
Yes. It will, because it crosses, right? It has to cross 70 and then it has to be positive time.
Oh, right. Yeah.
Otherwise, you've done a mistake if it is not positive, right? Okay. Last question for you, Amy. Can you please read this question and answer?
Yep. A stone is thrown vertically downwards from a point 100 meters above the ground with velocity of 6 meters per second. A. Find the speed at which the stone hits the ground.
Perfect.
Okay, so we need to find the v, final velocity.
Yes. So v square minus u square equals to 2as is the formula to be used, correct?
We've got s, which is 100 meters. Our initial velocity is 6, and our acceleration would be 9.8 positive because it's in the downward direction.
Got it.
Right. And then you just sub the values in. Okay.
Part A is done.
Yeah.
Right. Part B.
Find the time it takes to reach the ground.
Yes. Time v equals to u plus 8.
Right. And then you just rearrange, make t the subject, sub the values in. Yeah.
Perfect.
Right.
So that is how you do these questions, right? So I hope your concepts are absolutely clear, right? And during past few years, I've seen these are the questions which are normally asked on this topic. So
All right.
that should be perfectly good for you.
Yeah.
Perfect.
So I definitely learned from like today's lesson that drawing diagrams is actually really helpful, because when I see so many words, I can't really picture what's happening. But when you drew the building and then you said it's above this point and stuff like that, it was like really clear. So I know like which interval you're talking about and what the question's really asking.
Correct.
And then that whole acceleration thing, knowing when it's going up, it will be negative because you're opposing like gravity going down. So just knowing that. And then the key point from today was you need to find the initial velocity. And if it's not given, find that first. Or like when you know it reaches maximum height, you would know probably that zero, or there would be a value, because otherwise you can't solve the
Correct.
question because none of all the formulas have u in it. So yeah, you got to find the initial velocity. So yeah.
That's great. I mean, so I hope you have got all the concepts. Try to do some questions from your book and let me know if there is any difficulty. Right?
Right. Thank you so
So
much, sir. It was
my
a really
pleasure.
good lesson. Thank you.
Have a great day. Thank
Yeah,
you.
you too, sir. Bye.
Bye.